Right, featured in this video is the Riello MPT 100 UPS system. It's connected to a three-phase load bank, resistive load bank. Not shown are the battery banks that will be in a separate room but are connected to the UPS system. All right, let's start with connecting our UPS. On the left-hand side is the main supply input. Then we move on to the bypass supply input, battery connections, positive and negative, the neutral for both incoming and outgoing power, and of course the three-phase output. Okay, here's a block diagram of the UPS. On the left-hand side is the main and bypass inputs. For applications that require two separate sources, a bus bar internal to the UPS can be removed that links the main input to the three-phase bypass input. For this presentation, the bus bar is in place, so the main in also feeds the bypass in. The main input power feeds the rectifier, of course that converted to DC, powers the inverter through to the transformer, through the static switch, and of course through to the output or our load. The purpose of the static switch is to maintain power on the load should a fault occur on the inverter. So in other words, if there's a problem with the inverter, the static switch will automatically fire, thus maintaining integrity on the load. In between the rectifier and the inverter is our battery, our battery system, and of course the battery charging system. The switch gear panel is next. On the left hand side, the switch labeled SW-in is the main rectifier or the main input switch gear. We then have the SWBY, which is the bypass switch input. Next to that, there's a fuse bank for CPU system fans and control system. On the right-hand side, SW out is the main output switch gear. The bottom switch is the maintenance bypass switch, and we'll be discussing that a bit later. Right, we're going to start by turning the bypass switch gear on first. The UPS power controller is now powered up. Right, next we turn the main input switch gear on, SW-in. Right, next we're going to turn the output switch gear on, and so our load will have power. Okay, time to close the battery isolation. Okay, what we're looking at is the display powering up as the SW bypass switch is turned on. Okay, so the UPS control is now active. The rectifier and the inverter is off. Only the static bypass is available. Everything else is off. The rectifier symbol flashing indicates that the SW-in or the main input is now turned on. Right, SW out is now on, so of course the load now has power. The UPS is now in a normal operating mode. Top bar indicates load capacity, currently at about 10%. Bottom bar indicates battery capacity. These batteries are fully charged. The LEDs are indicating that the static switch has power, the rectifier has power, and on the right hand side the inverter is functional. Green lights, all good. For the power down procedure, we start with the batteries and we isolate the batteries from the UPS. Output is switched off next. The main rectifier supply turned off next. Now the bypass supply turned off, and this completes the power down process. Okay, for the maintenance procedure, we're going to bypass the rectifier and the inverter, so the load sources power directly from the main input. Once the maintenance bypass switchgear is closed, the supply in, SW in, and the bypass supply switchgear can be opened. The batteries will also be isolated from the UPS. Okay, and finally we open the battery isolators, and this removes all power from the UPS. And this is now switching back to normal operation, turning the maintenance bypass breaker off. Go ahead on it. Bypass on. The display will fire up. CPU started. Capacitors pre-charging. Rectifiers on. The battery charger is going to be turned on. And the output now can be turned on. Maintenance bypass off, and the load is still active. Load is not being compromised. Okay, we can now open the main UPS front panel. And what's critical in the UPS are the extraction fans. Make sure that these are rotating freely and are free of dust. The use of an electric blower or dust extractor works very well in removing dust from the fans. And inside the UPS where the heat sinks are, ensure that that's free of dust, and just a general clean out of the machine, ensuring there's no dust in any of the active components, PC boards, etc. A visual inspection of the UPS is also called for. Ensure there isn't any arcing going on or anything that looks suspicious. Once you've done all of that, the front panel door can be reclosed, and the power up procedure can begin again. All right, next we're gonna do some customizing. Okay, so over here we can change the output voltage of the UPS. It's currently set to 230 volts, and by using the 7 and 8 buttons we can adjust the output voltage. Next, the battery, and over here number 4, and over here we can change the battery charging parameters, the minimums, so in other words when the batteries will disconnect when you're on UPS power, the float charge, and of course the boost charge when it's busy charging. And these values can be adjusted by I'll just do it over here. 7, 8 changes that. 5 and 6 changes the float voltage, and the minimums are adjusted by 4 and 3. Once you've done with that, you can go out, 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 and away you go. For applications that require remote UPS health checks and diagnostics, the Netman 204 will stream important UPS operational data via a network to a web browser anywhere in the world. For this demonstration, the Netman 204 is configured with a static IP address and using Google Chrome to view its web pages. The dashboard indicates all essential operating parameters and data. At a glance, input, output, and load conditions can be assessed, as well as any alert the UPS may have generated. Battery test and authorized static bypasses can also be remotely activated. Log files can be accessed and downloaded for remote diagnostics. The email facility is essential in alerting relevant personnel with UPS status, errors, and other operating parameter changes. The Netman 204 is an essential option for UPS systems in remote locations.